Okay, so Mr. Show up and go over transformations. That's one of the four concepts this week. It's the third video I'm making. Transformations just is another word for change, and we have some three basic types of transformations right here: reflections and rotations. That's changing where the shape is on the coordinate plane. This dilation just means making things. We have, obviously, not only in math but in English, we have bigger words for things that are just simple. Dilation just means make bigger. Transformation just means change. So we're going to see how we go about and do this. Here's an old school way to do it, non-mathematically. Here's the problem. It says we have this triangle here with points A, B, and C. We want to reflect it over the y-axis. Here's our y-axis right here. Here's y, here's x. Reflect over the y-axis means we want it to reflect just like it went boop right here, flipped on its other side over here. So point B needs to be back here somewhere on the y-axis. The old school way to do it without doing any math is, okay, my point A is right here. I'm going to leave it, this is at 1, 2, 3. I'm going to leave it at 1 on the y-axis, but it's 1 unit over here, so I'm going to go 1 unit over here. I'm just going to move it the same distance it is from here to the y-axis. Has to be the same distance to the y-axis over here. Same thing over here. I can move point B. This is 1, -1, -2, -3, -4. I'd have to move B 4 units over here, but on the same plane. So B would be approximately over here. And I think you get the hint of what's going on there. That's one way to do it. Here's the math way to do it. Earlier this week, I gave you a cheat sheet. When you take the quiz, it's open note. You want to look at the cheat sheet. The cheat sheet's 1 page. It's a PDF. It gives you the formulas for every single scenario. And here's a scenario for reflect over the y-axis. The scenario is -x, y. And we need to know, what do we do with that stuff? Well, here's all our x and y coordinates. We probably knew in 7th or 8th grade, x comes first, y comes second. That's how we write a coordinate pair. Okay, so what does this -x, y mean? Does it mean making x negative? Because x is already negative right here, -1. Negative here means change the sign. Change the sign. And it says, and it gives you the order we're going to change things to. If it said y first, it means flip the y first and the x second. I'll show you that in a second. But all it's saying is the only change we're going to make, x and y, going from this, read this in green, x and y, to -xy, the only change we're going to make is we're going to change the sign of the x. So I can come through here and I can say this is going to be 1, 1. The y's, I can actually come in here and fill in all my y's. Why can I fill in the y's? Because look at the formula, y is not changing. Y is still y, and y is still after x, so it's not changing. But I gotta make all my x's change the signs in my x's, so this b is gonna become +4, this 2 is gonna become +2. And if you see what's happening right here, making them positive is turning that reflection in, because the y isn't going anywhere. A's still at the same position on y, which is 1. B's still at the same position on y, which is on the y-axis, which is 3. C is still on the same position on the y-axis, which is 5. They're just getting moved around from -2x to +2x. C's over here now. Now here's our reflection, okay? So that kind of explains reflections to you. I want to tell you, kind of in case you don't get a reflection, here's how we do things. Say you got something crazy like this. -yx. -yx. That says to you two things. It means you have to change things to where y comes first, and you have to change things where y changes the sign. Changes sign. So if I was going to use these same 3 coordinates with this formula right here, I put the y's first. 1, 3, 5. Those are all my y's. I would put them first, and I would change the sign of y. These are all positive. I would make them all negative. In the formula, the only change in x is it comes second. So these values, -1, -4, -2, they're not going to change in value. They're just going to move position over here to last. Why is that? Because that's what the formula tells you right there. And this right here in green, this is called A prime B prime, C prime. Those are new points for A, B, and C for the reflection. Thank you.